Okay, so we're going to go over the right bisector of a chord. Okay? Which means we're going to define a couple things, and we're going to talk about circles before we actually get into this question. A right bisector. Anyone remember what that means? What does bisect mean? Yes, to cut in half. Okay, so bisect means to cut in half. So in other words, if we're talking about chord, and a chord is a line that goes from any 2 points on a circle that does not go through the center. If it were to go through the center, it would be considered what part of the circle? Diameter, and then half of that would be the radius. So a chord is any 2 points that don't go through the center, okay? Something like that, or the red one we have, AB here. So, the right bisector of a chord, that's what a chord is. Our chord is this AB here. There's many different types of chords. A right bisector, well, bisect means to cut in half, so let's assume this is roughly half of it. And right stands for creating a right angle from a point. So if this is our line, to be a right angle of this, it'd have to be perpendicular. Okay. So a right bisector cuts a line in half and then creates a new line that is perpendicular to the old one. So that's what they mean by right bisector. Now, we have 2 points, AB. It says in the question, verify that the right bisector of a chord, AB, goes through the center of the circle. Okay. The center of this circle is at 0 and 0, though they haven't written it down here. We should have put it in. The center is at 0 and 0. So we're going to say C is at 0 and 0. Okay, we do know that information. We have to verify the right bisector of the chord goes through there. Now, there's a couple things I want to talk about. First of all, from the center, is there a difference in distance from the center to B and the center to A? Why not? Yeah. Because it's a circle, what would they both be considered? The radius. Both of these can represent the radius of a circle. Okay? So what we're going to verify here is that the right bisector of any chord will cut through the absolute middle of the circle. Okay? So this is a rule with circles that you guys are going to need to know. So we're going to have to find the right bisector of this. Okay? Well, the right bisector. Bisect means to cut in half, like we said, so we're going to need our midpoint formula. Okay? X2 plus X1 divided by 2, and Y2 plus Y1 divided by 2. We're going to take these coordinates. We'll call this coordinate 1 and this one coordinate 2. So when we plug them in, we add our two X values, which are 2 and 4. Divide that by 2. And then we're going to add our two Y values, which are negative 4 and 2. And we're going to divide that by 2. What is 4 plus 2? Divided by 2? 3. Okay. So we have 3. And then negative 4 and 2 is plus 1. Sorry, divided by 2 is 1. I gave the answer earlier. Okay. So, the midpoint, and of course it's negative. Good point. 3 and negative 1. So the midpoint of this chord is at 3, negative 1. Okay, that looks like it could be the midpoint. Perfect. Now, the next thing we have to do to find a right bisector is we need to find the original slope of AB and then find or transfer the slope to be a negative reciprocal. Okay, so again, we got to use those same coordinates, but this time we're going to use our slope formula. Okay. Recall that slope, or m, is equal to y2 subtract y1 divided by x2 subtract x1. I'm not sure why I'm going up. Okay. So again, we look at our coordinates quickly. Y2 is 2. Y1 is 4, so we subtract negative 4. And then x2 is 4, and we subtract 2. This will give us our slope. What is 2 subtract negative 4? Good. 4 subtract 2? Our slope is 3. So the slope of the original chord AB is 3. So if we need to find the negative reciprocal, I'm going to represent it like this. Negative reciprocal. What would the negative reciprocal of 3 be, Ethan? Good. Because imagine that this is a fraction. We flip it. We get negative 1 over 3. So that's the slope of the new line we need. Okay? So we try to find the equation of this right bisector. Well, we know our equation of a line is y equals mx plus b. Our m is going to be the new slope, negative 1 over 3. And there is a point on this line we do know. What point is that? The midpoint, which is what? 3 and negative 1. Hence why we had to find it. This is an x and a y value. We're going to take that x and y value and plug them in for x and y in this equation. So y being negative 1 and x being 3 plus b. It'll help us solve for b and give us an actual equation here. Okay, negative 1/3 times 3 is just negative 1. Okay, plus b. What is negative 1 plus 1? So b equals 0. So the equation of this line is then y equals negative 1/3 x. Do I have to add 0? No. Right? Because 0 is not going to make a difference. So here's the equation of our right bisector. We'll zoom out a little. We have the equation of our right bisector. And we wanted to make sure it went to the center of the circle. What point do we know was at the center of the circle? 0 and 0. So we need to figure out if I plug in 0 for y and 0 for x, does this equation stay true? Well, let's figure it out. 0 equals negative 1/3 times 0. Is this going to be true? 0 times a negative 1/3 is 0, and the left side stays 0. So the left side will equal the right side. So we know this true. This to be true, sorry. It goes right through. Now, let's say this question was a little different, and they actually gave us 2 chords, and they asked us to find the center of the circle to verify exactly where it is. Okay, so I'm going to zoom in again. I'm going to change it up a bit. Here we have another point. Okay, this point's at negative 4 and negative 2. So we have another chord here. I don't know what color that is. That could be it. Not really. Yes. We have our chord. This is point C. Okay, so I now have 2 chords. We already did the right bisector to one of them, and we found the right bisector to be going right through the origin. Okay, so we already discovered that equation. Okay, and it was y equaled negative 1/3 x, correct? Well, I'm going to do the exact same thing. And what we're going to discover is the next right bisector that I create from AC. It's going to bisect this line, and it's going to go right through at the center of the circle. So the point of this being is that the right bisector of any 2 chords will intersect at the center of a circle. Okay? So we got to go through that process again for AC. And we're going to do it very quickly because we've already done it once. So I'm just going to bring the points negative 4, negative 2, 2, and negative 4 down to the bottom here. So our points were negative 4 and 2. Negative 2, thank you. And what was the other one? 2 and negative 4, I think. We're finding the other right bisector now for the other chord we just drew. We just drew a new chord, AC, and we're going to find the right bisector. So again, we're going to have to find the midpoint, then the slope of AC, and then create an equation for the right bisector. So we have those numbers. What was the very first thing we did to find a right bisector? Midpoint. So let's do midpoint quickly. We already know it. I'm not going to rewrite it again. Midpoint, we add the 2 x values. So negative 4 and 2, and divide them by 2. And we add the 2 y values, negative 2 and negative 4. Our midpoint, negative 4 plus 2 is negative 2, divided by 2. Negative 1. Negative 2 plus negative 4. Negative 6 divided by 2, negative 3. Okay, so our midpoint, let's jump back up. Negative 1 and negative 3. Yep, that looks like it works perfect for us. We then got to find the slope of those two. These coordinates again, this was our coordinate C and this was our coordinate A. Let's find the slope of the two. Slope we know is y2 subtract y1, so I'll call this, that's our A. Coordinate 2, coordinate 1. I know this one's a little less organized, but we've already gone through these steps. Y2 being negative 4, subtract y1, which is negative 2. So we're going to subtract negative 2. Divided by x2 being 2. We're going to subtract x1, which is negative 4. Negative 4 subtract negative 2. Good. 2 subtract negative 4. 6. What's our slope? Negative 1 over 3. Okay, but we're finding the right bisector. So the negative reciprocal of this slope, Matthew, is just 3. Does that seem similar to anything else we did? Yeah, if you guys notice, and it's because of the points I chose. It won't always be the case. But because of the points I chose, we end up getting negative reciprocals in terms of our slope. So our slope is now 3, and we have a point on the line here. So we got to find the equation of this line. Okay. So our equation of a line is y equals mx plus b. Our new negative reciprocal slope is 3. So m is 3. And our coordinates, we have an x and a y. Well, we'll plug those in for x and y and solve for b again. Y being negative 3, x being negative 1, plus b. What do we end up going to find here? This is going to be negative 3 plus b.
Negative 3 plus b, so b equals 0.
B equals 0. Does that make sense? Why does that make sense? The y-intercept is what? 0, and the center of this circle is 0. We already proved it, but let's just say for this. So now, our new chord, we'll do it in purple here, I guess. Our new chord, we know, goes from this point through the center of the circle. Okay? And the center of the circle we've now verified is 0 and 0. Now, if they hadn't given us 0 and 0, there would be one more step to this. What do we find? Y equaled 3x. Is that what it was? Yeah. Our new equation for this right bisector, y equals 3x. And the other was, this was the equation for this right bisector. What if I had to find the center of the circle and I didn't quite know where it was? Maybe it wasn't at the center. What would I do with those two equations? Where do they intersect? I don't want the coordinate, the middle. They intersect at the middle of the circle. So if they had asked me to find the middle of the circle, what would I have to find with those two lines, right? Not the diameter. Coordinates of what? Where they intersect. We got to find out where they intersect, which is what chapter? We did this a while ago. Chapter 1. You remember when we did substitution, elimination, all that stuff? So, the equations, there's a lot of stuff here. Kind of do this on the side, just to an extra proof here to bring it around. Our equations were y equals negative a third x, and the other equation was y equals 3x. Those were the equations of our right bisector. So let's substitute. I know 3x is equal to y, so I'm going to sub it in here. We get 3x equals negative 1/3 x. Okay? And we're going to try to figure out what our x is going to be when we go through this question. So what we can do here is we can bring over 3x to the other side of the equation. So we get 0 is equal to negative 1/3 x minus 3x. What's that going to give us? You want me to put this in fractions or decimals for you? You guys falling asleep here or what? Okay, I'm going to do this in my head for you. That's going to be 2 2/3. Okay? That's going to give us, or sorry, no, it's going to give us negative 3 1/3. Which will be, okay, we'll turn it into a fraction. If I turn this into a fraction, this becomes negative 1/3 x. I need the same denominator if we're going to subtract fractions. Remember those rules? So I got to multiply this by 3, gives 9/3x. When I add those together, and this is still 0 on this side, I'm going to get negative 10/3x. Okay? Now, here's the funny part. I got to move this fraction to the other side, so I got to multiply by 3, divide by 10. When I do that to 0, what's going to happen? It's still going to stay 0. So what is our x going to equal in the end? 0. Okay? Our x value being 0, which makes sense if we're substituting. Remember, our origin's at 0. Well, I then take that 0 and plug it into one of these equations. That's our substitution method. I'll do this equation here. Y equals 3 times 0. What's our y value? 0. So the origin is at 0 and 0. I found the point of intersection. So, one of these questions for a chord, this would be the biggest question you could possibly have for a chord, is quite a bit of work. Okay?
So what if, like, they just give you, like, A and B? What would you have to do?
If they only give you A and B, you could only find one right bisector. You need 2 chords in order to find the center of the
So they
circle.
basically just give you A, B, C, and D?
If they give you 2 chords,
Yeah.
you need to find the right bisectors of both, which we did by finding midpoints and slopes, and then the equation of a line, and then midpoint, slope, the equation of a new line over here. And then you got to find the point of intersection between the 2 chords.